Hi guys and welcome back. In today's practice session, we're going to practice questions from the topic coordinate geometry, focusing on midpoint, gradient, and distance of a line. I encourage you to get involved in the process once again, as mathematics is not a spectator sport. The only way to gauge your performance for success is by getting into the sport itself. Let's practice. Now our first practice session is going to be on midpoint. Now we know midpoint means, as the word says, midpoint. So it's halfway between two given points on a line. So if I have the points A and B, so A is right here and B is right here, then the midpoint is going to be halfway between the points A and B. So if my A coordinates are x1, y1, and my b coordinates are x2, y2, then the midpoint is going to be half of the sum of the x coordinate, the x part of the coordinate, and the y part of the coordinates. So let's look at that example. If a line passes through the points A, -2, 5, and B, 4, 1, calculate the midpoint of the line. Now, for some students, they may need to identify what their x1 and y1 is going to be, or what their y2 and x2 is going to be. Now, in the case of a midpoint, it's not significant because multiplication and addition are commutative. Hence, anyhow you set the x part and the y part, you're still going to get back the same value. But for some students, and for the sake of this video, we're going to highlight our x1 and our y1 and our x2 and our y2. So we have the point A, -2, 5. So this can say let -2 be our x1 and 5 be our y1. And then we have B is 4, 1. So we can say let 4 be our x2, y2. And you could interchange them. Still wouldn't make a difference. You could make this A be the x2, y2, and let B be the be the x1, y1. It still is not going to change the answer. So hence the midpoint is equal to, add our both x's, -2 plus 4 divided by 2, comma, 5 plus 1 divided by 2. Now, midpoint is equal to -2 plus 4 gives us +2 divided by 2, and what plus 5 gives us 6 over 2. So the midpoint is equal to 1, 3. So the coordinates for the midpoints are 1, 3. So if I were to draw the points -2, 5 and 4, 1 on a graph, if I'm to bisect that line in two, if I'm to find that line halfway, it's going to be at the point 1, 3. So for the midpoint formula, we use x1 plus x2 or x2 plus x1 divided by 2, comma, y1 plus y2 or y2 plus y1 divided by 2. Now, if we want to find the length of a straight line passing through any 2 points on the same line, then we can use the formula square root x2 minus x1 all squared plus y2 minus y1 all squared. Now the order doesn't matter. If you put x1 before x2 or x2 before x1, it's still not going to change the answer because everything is going to come out all squared. And if you have y1 before y2, it still won't change your result because everything will come out all squared. Now question, if a line passes through the points A, -2, 5 and B, 4, 1, calculate the length of the line. Now, we still need to establish, for some persons, we can establish what is our x1 and our x2 or y2 and our y1. So given the coordinates, A is equal to negative 2, 5. So that's my x1, y1, and B is 4, 1, and this will be my x2, y2. So we're now going to substitute the values into our formula. So we're going to substitute values. So we now have AB is equal to the square root of x2, which is our 4, minus x1, which is negative 2, all square, plus y2, which is equal to 1, minus y1, which is 5, all squared. So we have AB is equal to the square root of 4 minus negative 2 gives us 6. So we get 6 squared plus 1 minus 5 gives us negative 4 all square. So AB is equal to the square root of 6 squares is the same thing as saying 6 times 6, it gives us 36. And negative 4 times negative 4 gives us 16. So now we can go ahead and add 36 plus 16, and that gives us square root 52. So AB is equal to the square root of 52. And because it's a length or because it's distance, it's 52 units. Now let us look at if we had let x1 go before x2 and y1 go before y2, what would have happened? So we could say AB is equal to the same square root, and our, this time we're going to say y1 minus y2 and x1 minus x2. So the square root of x1 would be negative 2 minus 4 plus y1, which will be 5 minus 1 all square. So we have AB is equal to the square root of negative 2 minus 4 gives us negative 6 all squared, plus 5 minus 1 is 4 all squared. So we still get AB is equal to the square root of 36 plus 16. So AB is equal to the square root 52. 52 units would be our final answer. Or if you would want to write your answer as a decimal, you can go ahead and do so. Now, the gradient of a line is the rate at which it goes upwards or downwards. Another name for gradient is slope. Now, the slope can either be positive or negative, and the sign indicates whether the line slopes upwards or downwards from left to right. So this would be a negative gradient, this would be a positive gradient, and a horizontal line would mean that our gradient is equal to 0. Now, the symbol that we use for gradient is small m. Small m, and we use capital M for midpoint and common M for gradient. The formula that we're going to use is y2 minus y1 over x2 minus x1. Or, as I said earlier, it doesn't matter if you want to put the y1 before the y2 or the x1 before the x2. The sign is what is important. The sign will come out the same in the end. So, key pointers to note: parallel lines have the same or equal gradient, and the product of the gradients of perpendicular lines is 1. I use the formula m1 times m2 is equal to negative 1. So if I know the gradient of a perpendicular line to my line, to the original line, when I multiply both gradients, I'm going to get my -1. Now let's practice the concept of gradient with these two questions. So 2 points on a straight line are 2, 6 and 10, 14. Calculate the gradient of the line. So we know that the gradient formula is m, m is equal to y2 minus y1 over x2 minus x1. Or we could stick to y1 minus y2 or x1 minus x2. It doesn't matter which one of the formulas you want to use, still going to be the same answer. Hence, m is equal to, let's establish what our x1, y1, x2, y2. So we have y2, which is 14, minus y1 is 6 over x2 is 10 minus y1 is 2. So we have 14 minus 6 gives us 8, and 10 minus 2 gives us 8. So our gradient is equal to 8 divided by 8, 1. So we have, then in our next question, the gradient of a line joining the points A, x9, so we have an unknown here, and B, 2, 8 is a half. Calculate the value of x. So it's an application question where we already know the gradient. So m is equal to y2 minus y1 over x2 minus x1. Now we already know the value of our m, but one of our values for x, our x1 is going to be missing. So let's plug in what we have first. So m is equal to a half. Let's identify this would be our x1, y1, x2, y2. So we have y2, which is 8 minus 9 over x2, which is 2 minus, and our x1 is x. So we can keep it as that. Now we can do what we call cross multiplication in some cases, where we can easily, let me just write it a little better. We can cross multiply to find the value. So let's simplify this some more. So half is equal to 8 minus 9 gives us -1 over 2 minus x. And we can apply our cross multiplication concept. And then we have 2 minus x is times 1 will give you back 2 minus x. And then we're going to have 2 times -1. So we now have 2 minus x is equal to -2. We're going to apply solving for equation, solving for x. So we have -x is equal to -2 minus 2. So -x is equal to -4. X is equal to +4. So therefore, the value of our x is equal to 4. Now, another question. The points A, B, and C are 8, 7, 11, 3, and 3, -3, respectively. And we know that respectively means the first point would be 8, 7, the second point, which is B, which would be 11, 3, and the third point, which would be 3, -3. Now, find the gradient of the line parallel to AB. Now, what do we know about the keyword parallel here? Parallel lines have the same gradient. Hence, finding the gradient of AB is finding the gradient of any other line that is parallel to AB. Hence, gradient is equal to y1 minus y2 over x1 minus x2. I'm using the 1 subtract the 2's in this case here. It doesn't make a difference. So m will be equal to, what's our points? Using the points A, and A is 8, 7, and B is 11, 3. So this will be my x1, y1, x2, y2. So hence I can say 7 minus 3, so 7 minus 3 over 8 minus 11. So m is equal to 7 minus 3, 4, and 8 minus 11, negative 3. So our gradient will be negative 4 over 3. Hence, therefore, the gradient of any other line parallel to AB is going to be negative 4 over 3. So the gradient of any line parallel to AB is negative 4 over 3. Now part B asks us to show that AB is perpendicular to BC. Now this could be proved using other concepts like Pythagoras theorem and stuff, but for the sake of gradient, we'll stick to gradient. Now what do we know about perpendicular lines? Now perpendicular lines, their gradients when multiplied comes to negative 1. So if we know the gradient of AB, that's negative 4 over 3. Now let's find the gradient of BC. That would be great. Let's call it M2 and let's calculate that. So that's going to be our y1 minus y2 over x1 minus x2. Now let's write out the points B and C. So B would be 11, 3, and C is 3, negative 3. That could be my x1, y1, x2, y2. So hence gradient. So we can have 3 minus negative 3 over, we now have 11 minus 3. So that's going to give me 3 minus negative 3, that's going to give me 6 over 11 minus 3. That gives me 8. Hence, we can reduce our fraction to give us 3 over 4. Now, the thing is, for them to be perpendicular, the product M1 times M2 must be negative 1. So let's multiply them and see what we get. Negative 4 over 3 times 3 over 4 equal, let's break it down, 4 into itself 1, 4 into negative 4 goes negative 1, 3 into itself 1, 3 into itself 1, so our final answer is negative 1. So once the product gives us negative 1, we can say therefore they are perpendicular. So the products of AB times BC is negative 1. And it's the product of the gradients, not just product, the product of the gradients. Now our final question in this video, use the diagram below to calculate the gradient of AB, and the scale is 1 centimeter gives us 1 unit. So calculate the gradient. Now we could calculate the gradient using rise over run, or we could identify the coordinates B and A and use our formula. Any way you want to use it, no problem. But for the case of using rise over run, because gradient is also equal to the rise over the run. So when you have the diagrams, it's just quicker to use the rise over run concept. So if I'm here, 1 place, 2, 3 places on my run, so I'm going, my run is going to be 3, and my rise is going to be 1, 2, 3, 4, 5. 5 places up. So my gradient is going to be, m is going to be equal to 5 over 3. So you form a little triangle normally, then you get a nice little rise over your run. Or we could identify the coordinates of B. What would be the coordinates of B? If 1 centimeter is 1, and here will be 1, then here will be 2, then here will be 3, here will be 1, 2, 3, 4, 5, 6, 7. So we'll have B would be 3, 2, and A would be 3, 4, 5, 6. A would be 6, 7. So we could use it also with our y2 minus y1 concept. So we could test it and say M, let this be our x1, y1, let this be our x2, y2. We should get the same answer. We will get the same answer. Hence, let's go again. So say y1 minus y2 over x1 minus x2. Sorry about that. It's x1 minus x2 hence M, what's my y1? That's going to be 7 minus 2 over, what's my x1? My x1 is going to be 6 minus 3. So we have 5 over 3. It doesn't matter which way you choose to do it. The gradient would be the gradient. Thank you guys for watching. Next in our series, we will look at the equation of a straight line in coordinate geometry. Thank you for watching.